of course, no calculus topic will be complete without some ability to apply it to a real life problem, and physics is always our favorite go-to, right? So we're going to have a basketball that's tossed straight up in the air. It reaches a high point and falls to the floor. And every time it bounces, it rebounds to 0.8 of its previous height, right? 80% of 20 is 16, 80% of 16 is 12.8, and so on and so on and so on, right? It's going to bounce less and less and less and less. It has an initial height of h0, which is equal to 20. So the first mission we have is to find a recurrence relation for that sequence. So for part A up here, h sub 0 was equal to 20. I mean, you can see it right there. There's h sub 0. H sub 1 is equal to 16, but 16 is 0.8 times 20, right? That's what that means, right? Rebounds to 0.8 of its previous height. Notice the previous in there, right? All right, so H2 would be 16, or excuse me, it's 12.8, which is 0.8 of 16. H3 is 10.24, which is 0.8 times 12.8. So rather obviously, we have a recurrence relation going on here. So it would be that h0 equals 20, and h sub n plus 1 is 0.8 of h sub n. I was unhappy with my curly braces there. There we go. Put a box around it. We're done. There's our recurrence relation. Now you notice that we were multiplying, right? Which means this is geometric, right? Because we're multiplying, I know this is going to be a geometric. Make a little note. And that helps me because then I know that the explicit relation, which is what they're asking for next, will involve a base and an exponential function, right? All right, so next part B. They want us to generate an explicit relationship. So explicit relationship doesn't look at this so much. It looks at the indices. So you can see it's going 0, 1, 2, 3. All right, so I need a relationship from n to that value, right? So this is h sub n, to 16, to 12.8, and to 10.24. I need something that would let me multiply. And I know that the 0.8 is involved because when I multiply, my recurrence relation means it's geometric down here. All right, so my explicit formula, I can define it a couple ways. H sub n is equal to, all right, I know I'm going to be taking 0.8 to the something. Right? That much is definite. Now let me try if I try n in here. So if I try n, 0.8 to the n, and I'm going from 0 to infinity, right? Because it's implied that 0 is my first one, so I have to put that somewhere. So I'm putting it right here. This is a case, for example, where it would be very nice for us to we're using the whole numbers because they say it right here. See the h sub 0? So we use whole numbers. I didn't even mention it before. But by them saying it's 0, that means automatically I'm going 0 down here. All right, so then 0.8 to the n obviously isn't enough, right? If I put 0.8 to the 0, I'd have 1. So I need the 20 right here. Because 20 times 0.8 to the 0 will get me 20. 20 times 0.8 to the 1 will get me 16. 20 times 0.8 to the 2 will get me 12.8. And I can prove it to you with Desmos. And of course, we can always check our answers in Desmos. So this example, sorry, I labeled the last one accidentally as example 7. This is example 7. So I'm going to put in a table. I'm going to call it N4. And I'm going to say 0, 1, 2, 3. And then here, I want this formula to be what I just tried. 20 times 0.8 to the N4. And there it works. Beautiful, huh? So I've checked myself in Desmos, and sure enough, that is correct. That is the correct explicit formula. And that 0.8 that we see here is the same 0.8 we see here. Whatever you're multiplying by in your recurrence relation will be the base of your explicit formula. If you can tell it's geometric, then it works beautifully. All right, C. What is the height after the 10th bounce? Okay, well, obviously this is way easier with the explicit formula. I can also use Desmos, but hold off on Desmos. Let's try to do this a little bit. So for letter C, they want the height. Well, they want the high point. The height at n equals 10 and n equals 20, right? So h sub 10 would be equal to 20 times 0.8 to the 10, and h sub 20, 20, that's a subscript. Looks like H2O right now. All right, there we go. H sub 20 would be equal to 20 times 0.8 to the 20. And this is what Desmos is for, right? I can just go into Desmos. I can skip and just type 10 and type 20. I have a formula, so I can use it. So at 10, it's at 2.147 feet high. And at 20, it's about 0.231 feet high, if we round it to 3 decimal places. Like that. So part D says, make a conjecture about where you think this is going. Well, I think anybody who's ever bounced a basketball knows where this is going, right? The limit as n goes to infinity of that height function is 0, right? Gravity is going to make the ball stop, right? So gravity will eventually take over. Well, it's always there. Will eventually stop the ball from bouncing. If it's not bouncing, it won't have any height.